get started?
Yeah, might as well.
Okay. So this is the TCP Inc. working group. Congratulations on surviving IETF all the way to Friday. Here's the note. Well, it applies to everything that is said, done, posted, etc. in this meeting or in the working group. All right, Kyle. To the here.
Yes. Yeah. So, time for agenda bashing. Does anyone have anything to add here?
Here.
So, chair update, TCP-ENO, TCP-Crypt, and then I'll be talking at the end about some of the messages that the chairs sent to CFRG. And by chairs, I mean that I sent to CFRG.
Yeah, I decided to make it his problem.
All right, next slide.
He was surprisingly cooperative.
So since Berlin, there hasn't been a huge amount of work, but there were two very long discussions on the mailing list. Those two discussions, one of them was around the URGE and thin bits, and the other one was around SYN data, and both involved long, drawn-out discussions with Joe and some other folks that actually produced some very subtle semantic changes in the documents. But I think that as a result of that, the last remaining real blockers to work group last call have been resolved.
Yeah, this is the 90-90 rule of project management striking again. You know, the first 90% of work takes 90% of the time. The last 10% takes the other 90%. Speaking of which,
yes,
we're actually sticking fairly close to our milestones, unlike a number of other working groups, including one that I chair.
Yeah, I will point out, however, that sticking close to the milestones in this case means that we push the milestones back, I think, 3 times. So these dates are not the original dates.
Yeah, I don't think we're going to make January date for the API. We need to figure out what we're going to do about that API doc later in this meeting.
Yeah, so actually, that's a good question. Did we want to add a specific agenda item for discussing the API doc? Okay, so why don't we do that after? I want to put mine last just to maximize the potential for TLS people to be in the room. So why don't we put it third, so after TCP Crypt.
Okay, let's quick check. Aaron, you still willing to take notes for us? We've basically decided that we're gonna put a slot at the end of the agenda to talk about.
Back up.
Here, sorry. Where's the agenda? We've decided that down under open mic.
No, we're after TCP Crypt, but
after
before CFRG questions, we're going to talk about the API doc.
Yes. Okay.
No, after TCP Crypt, the first on the second column.
Yeah, TCP-ENO, then TCP Crypt, then API doc, then CFRG questions, and then anything else. Thank you. Anybody in the Jabber room? Okay.
So anyone willing to scribe? Okay, we have a volunteer. Thank you.
Okay. Oh, great, Nats again. I got another working group with Nats. Not sure what we're going to do about middle box probing. Let's figure out what we do with the API doc, then we can figure out what we're going to do about middle box probing.
Well, thankfully, it's not a milestone, so.
Yeah, but that's wise decision up here on that one. Okay.
So yeah, and this is almost copied verbatim from the last presentation. We haven't gotten any bytes yet on independent implementation. So so I implore you, if you have any interest in this, please contact one of us, and we will direct you toward resources to get you started.
All right. Okay. So hang on a minute here. Let's see what am I doing. We want the ENO slides, right? Okay. Let's just see if this works. It does. Charge.
Okay. Great. So yeah, update on TCP-ENO. Went through a bunch of drafts right after the last meeting, and then a couple more recently. So just to remind everybody of how ENO works and what the goals are. So the goal is to facilitate adoption of future TCP encryption protocols. So we used to call these things encryption specs. We've now coined the term TEP for TCP encryption protocol. And so the idea is that when there are going to be new TEPs, because we didn't want to like try to be all things to all people and solve all problems. And when new TEPs come along, we don't want them to have to go through the trouble of getting a new TCP option kind, because those are limited and it's a pain to get them. We don't want, we want new TEPs to be incrementally deployable so you can fall back to existing ones. And possibly more importantly, once we get this stuff deployed, there may be applications that then take advantage of TCP-INC, and we want to make sure that those applications continue to be forward compatible with future TEPs. If you actually go through the trouble of integrating the TCP, the session ID, for example, in your user authentication, you want to make sure that that works with future TEPs. So the goal of ENO is to kind of abstract all these things away from the application. And so we also want to minimize consumption of option space, since that's at a premium, and avoid unnecessary round trips. And of course, because this has to be backwards compatible, we want to make sure we fall back to unencrypted TCP rather than causing connections to fail as much as possible. So just an overview of how it works. In the common case of a three-way handshake, you have an active opener who sends a SYN segment, and the SYN segment contains an ENO option, and inside that ENO option is a list of TEP identifiers saying, what TCP level encryption protocols are supported by the active opener. Then the passive opener replies with a SYNAC and replies with
Try it again. There you go.
Good. And so replies with ideally the one TEP that the passive opener wants. There's also this new change that we made last time, where you have to add this B bit here to say that you're the passive opener. And that was, in a way, I never want to say it's nice to have middle boxes doing horrible things, but we did have kind of like all these debates about should we have this like perfectly symmetric protocol and whatever, and all that turned out to be irrelevant because we found out that places like Baidu just like have these middle boxes that like echo any unknown TCP options back to the opener, and so it just had to be the case if somebody echoes your option that it just is disabled, because it would be disastrous to start encrypting when the other side didn't know that it was encrypting. So basically, one side has to set the B bit to 0, the other side has to set the B bit to 1, otherwise we fall back to unencrypted TCP, and that just makes a lot of things simpler. And then you, in the third leg of the handshake, you keep sending the ENO option to make clear that the ENO didn't get stripped off the SYNAC segment, and you keep sending an ENO option until such point as you've received a segment that doesn't contain a SYN flag, and at that point, you're done, and both sides know that they're encrypting, and the connection is encrypted. If any of the ENOs or options are missing in the beginning, then you fall back to unencrypted TCP, and that's what gives us the backwards compatibility. Okay, so what's in an ENO option? Well, there's two kinds of ENO options, or two forms of ENO options. There's the ones that are in SYN segments and the ones that are in non-SYN segments. So at the top, you see in a SYN segment, the ENO option is basically a container for a bunch of sub-options. In otherwise, it's ignored, right? It's just the presence of the ENO option is a flag, but the contents is ignored by ENO, and unless the TEP that you've selected, that you've negotiated, specifies that you should put some bytes in there, it must be 0 bytes, so it's just an empty option. But it's available if the TEP wants it. Okay, so within the SYN segment, each sub-option starts with an initial sub-option byte, and that byte has two components. It has this high bit V, which stands for variable length data, and then it has a 7-bit thing that used to be called CS, but now we're calling it GLT, which stands for global sub-option length or TEP identifier. And we've sort of broken it up into 4 quadrants. When the GLT field is less than 32, then if V is 0, it's what we call a global suboption. We used to call that a general suboption. We think the name global is clear because those are options that apply across all TEPs. And if it's 1, then it's a length byte. And we used to have this more complicated thing with length words and whatever. We just got rid of that so that now it's simpler. And then for values of 32 or greater, it's a TEP identifier. That 7-bit value is a TEP identifier. And if the V bit is 0, then it's just a 1-byte TEP. Otherwise, it has variable length data. So in one more detail, there's basically 3 kinds of TEP identifiers that you can embed inside a SYN form ENO option. You have the single byte TEP identifier that doesn't have any data, it just says, hey, I support this TCP encryption protocol. Sorry, am I popping my P's or am I not loud? Oh yeah, sorry, because I don't have my slides in front of me. So I'll try to speak across the mic like this. Actually, I guess I can speak. Usually when you speak into a mic, you pop your P's, so it's better to talk across. But okay, so yeah, so here's the 1 byte when the V bit is 0. Otherwise, there's 2 options. If you just set the V bit to 1 and you set a TEP identifier, which is where the low 7 bits are 32 or higher, then it means that the data extends to the end of the TCP option. And we special case this because we think the common case is there's only going to be 1 TEP that actually has data, just because you don't have that many bytes inside a SYN header. And then the other option is that you have this length byte, and then you have a TEP ID with a V bit set to 1, and then you have that many bytes of data. So that way you can actually, if you want, have multiple TEP sub-options that have data. And then the other option is there's this global sub-option. The global sub-option starts with 3 0 bits, and then has 3 reserve bits that must be 0, and then these 2 bits A and B. So the low bit B, that's the thing that breaks the symmetry of the protocol. The passive opener always has to set B equal to 1. The active opener always has to set B equal to 0, although 0 is the default value if the active opener happens to omit this global sub-option. That's because, like, in the very first SYN packet, that's when option space is at the greatest premium. And then the second thing is this application aware bit, which is a bit that's available to the application to negotiate something out of band that triggers authentication of the TCP level encryption, right? So that's how you have some legacy protocol. There's no way to add like a start TLS command to it. The protocol is already fixed, but now you have this extra bit that says, hey, when we do our authentication step, if both of us agree that we're aware of TCP-ENO, we'll somehow incorporate the session ID in how we do authentication. If you remember last time, there used to be this M bit. We decided to push that off for later. We still think that there's room for application independent authentication protocols, and that we should negotiate those out of band. But we now have these 3 bits named Z3, Z2, and Z1 that we can use. So ideally, Z3, in some future draft, will become in a separate document would say, like, how could you combine DANE and TCP-ENO, for example. Okay, so you're only allowed to have 1 global sub-option. You have to ignore subsequent ones. That means if 5 bits turns out not to be enough, we could just say when you get a second sub-option, it has these 5 new bits that have 5 new meaning. So probably won't happen, but at least we're future compatible if need be. Okay, so now the interesting stuff. So this is probably the biggest change since last time, and we've had a lot of discussion on the mailing list. I hope that where we ended up made everyone happy. And that is, we talked about what does it mean for a TEP to embed data inside a SYN segment, to do something like TCP fast open, for example. So a couple things. So first of all, we said that when you have a SYN segment with an ENO option, the last TEP identifier in that ENO TCP option is what we're calling the SYN TEP. And the SYN TEP is responsible for defining the meaning of data that's inside that SYN segment. So in particular, if the SYN TEP doesn't say anything about SYN data, then you are not allowed to put data in a SYN segment, right? But we're leaving the option open for future TEPs that might wish to do this, right? And then, of course, the SYN TEP might turn out not to be the negotiated TEP, right? You might propose a bunch of TEPs. The last one is one thing. You embed a bunch of data for that, and it turns out that you're the active opener. The passive opener decides to choose a different one. So at that point, you have to discard the data because it doesn't because the data only had meaning to one particular TEP and you chose a different TEP. So we say that you have to discard the SYN data if the SYN TEP is not the negotiated TEP, including the case where ENO fails entirely and it's not an encrypted connection. We also say that you have to discard the data if there's any other TCP option that implies something about the meaning of the SYN data. So right now, the one that's most relevant would be TFO. So if you have a non-empty TFO option, you have to discard the SYN data. Basically, it doesn't make sense, because if you have the TFO option telling you, hey, this is some plain text application data, and you have, say, a SYN TEP telling you, like, hey, this is some part of a key exchange or something, then like, well, which is it, right? You don't know. So you're not supposed to use TFO in conjunction with this. So that's one safeguard, that you can't use the data if it's ambiguous what it means. The second safeguard is what happens if there's a host that receives this data and appears to discard it because it doesn't actually ACK the bytes that were in the SYN segment, but it actually caches those bytes anyway, and when you retransmit those sequence numbers with different bytes, it uses the cached original version of that. And because we don't know that TCP implementations don't do that, we say that we require you to do it if you implement ENO, but of course the other side might not implement ENO. So what that means is that if so that means is basically if the other side if the other side doesn't appear to support ENO and it is required to drop those bytes, then you actually have to abort the connection and send a reset, right? And so what that means is, of course, you don't want gratuitous resets. So that means you should avoid SYN-only data by default. So we're saying we're leaving the door open for this in the future, but we're saying it shouldn't be enabled by default. So either there should be a mode where you don't use that, or if your TEP always uses that, then that TEP shouldn't be on by default. But we're suggesting that the API might contain a flag that says, I know that TCP-ENO is going to be enabled, so just reset the connection. I'm only interested in talking over a TEP encrypted connection. And if the application is actually asking you to reset an unencrypted connection anyway, then it's fine to use these. And you're obviously not going to want to use that for web browsing or something, but it might make sense for like NFS or something where it's like you're on a LAN, that you're talking to a server that supports this, so you might want to just configure yourself to always require the encryption, and then you can save yourself a half a round trip, basically. Okay, so that's the one big change. And then looks like there's a question.
Yeah, simple question, because I looked up in the draft and I didn't find it. So this is only for session resumption, right?
No, this is for this is not for session resumption. This is actually in ENO. It's not in TCP crypt. So it's kind of, we're not actually using it in TCP crypt, but this is to leave the door open for future TEPs that want to subsume some TFO-like functionality. And what we're saying is it's fine if you want to do that, but it has to be off by default, and you're going to have to reset the connection if the remote side doesn't support ENO and you sent it a bunch of ciphertext or key exchange stuff that it probably doesn't understand, therefore you'll have to reset the connection.
Okay, so it's not actually application data you put in the payload. It's data you need for setting up the session.
that is up. It's up to the TEP, the specific TEP, and right now no TEPs actually do this, but one could imagine that it would be like if we did this for TCP crypt, it would be one of two things. In the case of session resumption, it would be encrypted application data, and in the case of like a fresh connection, it would be key exchange data or symmetric cipher preferences, or both. Okay, so the second thing is in either Berlin or Argentina, we've been at this long enough that it's starting to blur. But we became forcefully convinced that under no circumstances do we want TCP-ENO to be required to modify RFC 793. And so there was this problem that we were saying things like, well, you can have some mechanism for end of file that's separate from FIN, and the language kind of made it sound like maybe the FIN bit was no longer the FIN bit. And same for urge. And so instead, what we've done is we've rewritten these TEP requirements to make everything in terms of like authenticating the existing TCP mechanism. So we're not abandoning TCP mechanisms, right? So in particular, we say that, you know, TEPs have to authenticate the FIN bit, and you know, they can do that with some parallel mechanism, but if the parallel mechanism and the FIN bit don't match, then that means you've got some packet corruption. So either you can discard the segment that's corrupted or reset the connection with an error or something, but you can't treat it like an authentic end of file. And similarly, so this is where things get a little tricky. We want to kind of walk this fine line with urgent data, that it is part of TCP, but a lot of people don't use it. But like if people could inject urgent data, it could like mess up existing applications. So we want to make clear that you know, a TEP cannot cause urgent data to be delivered when none has been sent by the sender. That's really like the important thing. And the problem is that there's no way in hell that TCP use TLS is going to support urgent data properly, like exactly the way TCP does. TCP crypt does, but it'll be hard to fit into TCP use TLS. And so what we want to do is make sure that ENO can accommodate TCP use TLS, but not that we're like modifying RFC 793. In particular, you know, there's this more recent RFC 1693 that kind of reaffirms urgent data and talks about how it's supposed to work. So we have this thing, you know, it's maybe theoretically used by some really old FTP servers and maybe Telnet and RSH, which people aren't using that much anymore. It's not used by most applications. So basically what we did is we left this loophole that we hope is big enough to fit like TCP use TLS through. So we're saying that basically, you know, it's okay to, you know, you might have some TEPs that would just basically ignore the urgent flag, pretend it's clear no matter what, but you shouldn't enable that kind of TEP by default, except when you know for a fact that the application is not going to use urgent data. And like, it just happens that we know for a fact that almost all applications are not going to use urgent data. So that's our hope that we've managed to kind of thread the needle here.
Okay, let me say one quick thing about threading the needle. It's basically another way to think about the phrase everything in terms of protecting TCP functionality. From a functional point of view, one way to think about what's going on with the TEPs is that you've got crypto function between the TCP implementation and the wire, which means on receipt, you get to go do the decrypt, look at what the TEP put in there to tell you whether the FIN bit is authentic or not. And if the TCP header contained a FIN bit, but the decrypted TEP payload said no FIN bit here, at that point you discard it. The regular TCP implementation never sees it. And this basically, if all else fails, we can phrase this in terms of the processing sequence where you run TCP and then do the encryption, and on send and then on receipt, you do it in the reverse order. And that's how we can be confident that we're not going to need to update RFC 793.
Okay, so these are really the two big changes. This is kind of a summary of everything we've changed. We've got this new terminology that specs are now called TEPs. The general suboption became the global suboption. We've got this notion of a SYN TEP. We got rid of the length word. So now other than the last TEP suboption, you can only have 32 bytes of suboption data. But remember, the total space for all options is 40 bytes. Mm-hmm. So you're not going to have more than one suboption that's more than 32 bytes anyway. So again, this just simplifies things. We got rid of the M bit. We called the reserve bits Z1, Z2, Z3 to make them easier to name in future drafts that might use them. We talked about data and SYN segments. Another kind of change is that we changed some shoulds to musts. And for the remaining shoulds, we tried for everyone to like actually say like the exception is whatever, because basically we have pushback on the mailing list that you shouldn't just blindly throw around shoulds. If you're saying should instead of must because there's an exception, like explicitly state what the exception is. So we tried to be clear about that. And then, we tried to improve the wording for the TEP requirements. I already talked about the FIN and urge. The other thing is someone, I'm sorry, I forget who did this, but brought up the issue of forward secrecy on the mailing list and saying that, basically we didn't want to rule out some application, some possible implementation, right? You could, imagine an application where you have to like seed your system random generator from some seed file that's stored on an SSD, and because of your flash translation layer, like technically it's like really hard to do forward secrecy in that kind of scenario. But the important thing is we want at the protocol level, all the TEPs to offer forward secrecy. So basically we're saying like you can't depend on long-lived secrets on long-lived keys for secrecy. And that's it. So just a few tiny things left to do, I hope. So one question that we still have, I don't know if we've discussed this before, but should there be a way to signify that like a host implements ENO, but it's just disabled? And one reason you might want this is because it would help in the case of, in that corner case where you have to discard some SYN data that's like because the SYN TEP ended up not governing the connection. Well, if you know the other side implements ENO, even though it's not enabled, it'll discard that data. So that might be nice. It might also be useful in terms of like data gathering to be able to, people are willing to advertise, hey, like my kernel supports it, I just haven't turned it on yet. Then that could help make the argument that people should eventually turn it on because like it's at least the code is out there and it just needs to be configured. Another thing, I think this is just an omission, but we should have some kind of, in the API document, some kind of TCP-ENO mandatory thing that says, hey, abort the connection if I don't, if it's not encrypted. And that option would allow us to enable TEPs that do TFO-like things that have SYN data. Then we need to get our actual option. Still hoping we can get 69 since we had used that earlier. And yeah, I hope not much else. There's other stuff kind of following work, so we still need TCP-ENO middle box probing document. There's this experimental spec ID, so we'll need another draft that just talks about how to multiplex that, and I think some EXID-like thing. I think that should be very simple. And then, ideally, I'd also like to, see application-independent middleware authentication so that you can like load a shared library that, when Dane is deployed or whatever, it can actually do like server authentication transparently to the application. So this is different from the A-bit in that it would say like, here's a little mini protocol that you can do ahead of handing the socket over to the application. But again, we've got 3 bits and we could co-opt one of those bits for doing that.
Okay. A few suggestions from up here, and I'll go bottom to top since that seems to be that stack LIFO seems to be the way my brain is working this morning. Application independent authentication would be a fine follow-on. I would strongly suggest writing the draft against a specific mechanism, as opposed to writing a general draft that says you could do this. Figure out how to use Dane and write down the details. Yeah,
that's why we're not. That's why it's not part of the ENO. It's,
good.
We want to. Yeah.
Do you have any experience with the A-bit for application awareness in the prototyping you've done?
Yeah, Andrea did. It was a while ago, right? But didn't we use it in the original TLS?
So,
yeah.
We had a drop-in timer replacement for libcrypto.
Mm-hmm.
Do you want to go to the mic? Or I don't know if anyone's listening remotely, but
I've got 2 people on Meet Echo, so yes, please use the mic.
Yeah, so this is Andreas. So the question was whether we used the A-bit in our prototyping, and we certainly did. We had a drop-in replacement for libSSL, a binary replacement actually. And the idea was to use the A-bit if the other end, supported TCP crypt. We just kind of use TCP crypt and then do the authentication ourselves. We get the session ID using SSL, and if it didn't support the A-bit, we just did vanilla TLS, basically.
Reason for the question was to ask whether there was implementation experience with the A-bit to figure out whether it actually works, and it sounds like yes.
Yeah, that's
there is, and you've got an idea.
It was a slightly older version of TCP crypt, but the principle should be the same.
Right.
Same
Okay.
concept.
Cool. As opposed to the M-bit, which is something we'll come back to later.
Yeah.
Okay. Working our way up. Dedicated TCP option. Okay, I suspect Kyle's going to stick me as shepherd for this draft, in part because of this one.
Well, I believe you are the shepherd for this draft.
Okay, yes, okay. Game plan here. we get through working group last call first, and then we will, at that point, we'll figure out what to do. I believe the rough consensus of this working group is to ask for 69. However, I don't even have, I would ask Joe Touch to do a working group last call review. I suspect that request is not going to be necessary. Now, let's be serious. Joe is one of the people who has the best understanding and the most scars from fighting TCP options. So having him do the technical review during working group last call is very good. And as part of that, we get to go deal with which option number and whether 69 is. I believe,
whatever, any option is fine.
Well, I understand any option is fine. However, I'm pretty sure based on discussion, I think in Berlin,
Yes.
69. The rough consensus of this working group is to reuse 69. And we can then have an argument as to whether the working group is right or wrong about that, but we will have that argument on the list.
Yeah, I believe the philosophy behind that was you broke it, you bought it kind of thing.
Yeah.
So, which is fine. I think everybody was okay with that.
Yeah, and I mean, and if I recall correctly, Joe was arguing something even stronger, but at this point I'm going to stop trying to channel Joe. Finally, I would, speaking now as an individual, not your working group chair and not your draft shepherd, and I'll spare you the gratuitous walk to the floor, Mike, to make the point. I would suggest not doing the first item on this slide. This is already subtle, complex, and unlikely to be used. Let's just not do anything more that we don't need to do there, so we can get on with things.
The first bullet on which part of the slide?
The option way to signal ENO implemented but disabled. It sounds like you're proposing to add some additional functionality to cope with SYN data, which we don't expect to use anyhow.
Well, let me make this more concrete. What I'm proposing is saying that instead of saying you have to send one or more TEP IDs, you could be changing it to 0 or more. And if there's 0, then there's no negotiated TEP. But it's making it legal to send basically a gratuitous ENO option in a SYN segment.
This is sounding like gratuitous functionality that isn't crucial to getting the job done.
Okay.
So I'm going to have to, sorry, this Kyle Rose, not speaking as chair. I'm going to have to disagree with David on this. I actually think this is a really good idea for exactly the reason you specified, which is that it solves the problem of knowing whether a peer supports ENO but just has it disabled for purposes of dealing with early data. And it doesn't seem like it complicates the protocol in any way. So it seems like a good idea. If the client sends an ENO option, then you always respond with one if you support ENO, whether you have it turned on or not. And that solves the ambiguity regarding whether you have to terminate the connection if you sent early data or not.
Yeah, I mean, older versions, like really old versions of TCP crypt had some way of like declining or whatever, but so we don't feel that strongly, but it's, yeah.
Yeah, it could have been. Yeah, I don't see a big benefit of it because you anyway have to do the negotiation next time. You never know what was before, and then like I'm not even sure if you want to cache this information because next time you try something is completely different.
Well, one thing that's kind of like been a thorn in our side for the whole time is like people talking about you know, whether middle boxes are going to like strip options and this kind of stuff. So it'd be kind of nice to say like, you know what, like, okay, nobody's, you know, most people aren't using ENO yet, but like it appears that it gets through middle boxes. But again, it's not. Yeah. Well, if the consensus is don't put it in, then we won't put it in. It's a small change either way.
Can you further explain how it happens with middle boxes? Because if the other end doesn't support ENO, I don't know anything about the middle box in between.
No, I'm saying suppose that like, you know, ENO gets deployed, but just it's going to be off by default at first, right? And so people are going to want to know like, well, should I turn this on? And if you say like, oh, well, it does appear that like when I send an ENO option to this person, I'm getting one with the B bit set properly back, and that our path appears to be clear through this network, then that might encourage people to turn it on, to configure it on. So
I believe if you deploy the implementation and you have it turn off by default, what you want in this case is not having your traffic change at all, and you don't want to see new options.
Okay.
Also, it's also option space, right?
Yeah.
I don't think it actually matters. I mean, if you put it there, another end is going to ignore it anyway, because there is nothing to do with the ENO option, because there is no steps to negotiate. Yeah. the other end has to be able to ignore it anyway, because and fall back to the clear text anyway. So it doesn't affect any implementation if you allow it or not. It can allow you to do probing in cases where you for example want to do measurements, how many things works, and you can do this without. One of the things, for example, with IPsec, we're doing measure events, is always that you send a proposal and you get the same response whether IPsec is enabled at all, but it's still running, or if you just have a wrong configuration. This would allow you to do probing without caring if the other one supports TCP-INC or TCP crypt or TLS.
Wait, so you're in favor, or actually?
I think because it doesn't affect the normal implementations without, because yes, you just put it in there, and the other one just.
Okay, so you think that's okay?
Yeah.
So we've got 2 in favor, 2 against.
Kyle?
Yeah, Kyle Rose. Yeah, the two cases it helps are the probing case and the preventing spurious resets case. And I think maybe what we want to do is kind of go into more detail on the mailing list on the ups and the upsides and downsides of this, because Miria pointed out some good downsides to doing this, including option space. Yeah. And the fact that ideally you would like an implementation to have a way to say really turn it off and don't even send, don't even recognize that this option exists. But that adds complexity to the API. So I think outlining it on the mailing list and then making a consensus call there is probably the right way to do that, because I just want to make sure that everyone understands all of the implications of this fully before making a decision.
We'll want to try to do this fairly quickly on the mailing list so that we can get
it's not important enough it's worth delaying stuff, but it was just one thing that I noticed we kind of lost.
All right, it needs to be fairly simple.
This is Martin Duke. So we've talked a lot about the potential benefits or lack thereof of this, but can you give us a sense of costs? Did you try to implement it? Like how many paragraphs of spec is it?
It's like a changing a 1 to a 0. I mean, it's
well, no, it's more than changing 1 to a 0. You're also going to have to write a paragraph that explains what happens when the ENO option shows up on a SYN carrying no TEP payloads.
Actually, it's already clear. Then there's no negotiated TEP.
You're still going to have.
We get on one sentence to say yes.
You're still going to have to explain.
Okay, I'm happy to propose a diff on the mailing list that will be probably 2 sentences.
Okay.
And then
I can be convinced the other way. I mean, my immediate reaction was we're not doing SYN data. What was the point? But data gathering, I can see some leverage.
So if it doesn't make the RFC TLDR and it doesn't put an enormous burden on implementers and it doesn't take up a bunch of IANA space, I don't see any reason to not produce something that someone might find useful.
I think in my mind, the biggest downside is we might then need an extra API for completely disabled, or there'll be another value for the TCP-ENO enable. But
I could have so thinking about the middle box cases, would you also reflect a basically empty TCP-ENO option from the receiver back in with its SYNEC? Because otherwise,
you'd have to set the B bit to 1, so it wouldn't exactly reflect it.
Yeah.
But basically, the idea is if I send TCP-ENO to some server, and then the server supports TCP-ENO, but doesn't want to actually encrypt, it would just send back an empty TCP-ENO with B = 1, so it'd be a 3-byte option, including the kind length and the global option with B = 1, and no proposed TEPs, and then encryption would be disabled. But that would allow me to know that it would allow me to differentiate the case that the middle box was stripping off the ENO option from the case that the server didn't want to support it.
That's just for the reply, not for the initial SYN.
I mean, it could also be for the initial SYN. I don't know. That doesn't seem as useful. Just in terms of functionality in the spec, if we're gonna define what it means to have no TEP IDs, say it's 0 or more TEP IDs instead of 1 or more, we might as well have it in both. But I don't see. It would probably be more useful in reply from the server. But we could also have it be from the SYN for explicitly measurement stuff. I wouldn't expect implementations to want to do this by default, but we can make it legal so that to facilitate the measurement of how many middle boxes this would get through.
Yeah, what I was thinking is if you want the measurement case, you can at least say if you receive an empty ENO, you should reply to it so you can do the measurement. So you just specify what the receiver has to do and not specify that you have to do the
and make
probing
it make it legal for the sender to send an empty one, but not suggest that people do it.
Yeah. So that seems useful.
Yeah. Okay. Good.
All right. I think the path forward sounds like propose the diff on the list. Propose the text diff on the list. If it comes out as short as you think it's going to come out, we can run the consensus call on the list for this. But my concern up here isn't so much technical merit or lack thereof. It's a
column inches.
It's reasonably short path from here to working group last call, because I know that's going to be interesting.
Okay, good.
Yeah, we do have a history of doing a lot of work for the few weeks right around the meetings, and then like a long space in between where nothing seems to happen. So we don't want to wait until Chicago.
Yeah, I would very much. I mean, don't know about next month, because I have some, as Miria probably knows, I have some TSVWG stuff I got to deal with, but very much want to get these drafts to working group last call by January. Let's get over this.
Yeah. Okay.
All right.
That's it for me.
All right.
Now Andrea's up.
Let me go look at the slide. So we need TCP crypt. All right.
All right, yeah, so I'm Andrea. I'll talk about TCP crypt. So I'll start with a refresher on the protocol. So this is the four-way handshake of TCP crypt. We use ENO to signal support. And so in the first round trip, we do the negotiation for the public key ciphers. So in this case, the active opener is saying, yeah, I support P521 and P256. The passive opener replies saying, hey, let's go ahead and do, P curve 256. And it sets the passive opener bit that David talked about extensively. So the second round trip is about symmetric cipher negotiation and exchanging public key material. So in this case, the active opener is saying, I support AES 128 and 256. It sends its nonce and its public key. And the passive opener selects the symmetric cipher, in this case AES 256, and it sends its own nonce and its own public key material. So we basically extended TCP's three-way handshake by adding one extra leg for negotiation. And the fundamental reason for this was that public keys are large; they don't fit in option space, so we put them in data that is invisible to apps, and that's why we start sending key material only on the third leg, because that's when you could start sending data. So after we've done this key exchange, both ends compute their, they do their Diffie-Hellman or whatever algorithm they're using, and they get their key agreement result, which is not transmitted on the wire, obviously. That's how you get your protection against passive eavesdropping. So we take all that information, the key agreement material, and all the bits of the handshake, and hash that all together, and you get your session secret. From that, you derive your session ID. So you can see from this that intuitively, if you create a TCP connection and the two session IDs match, it means that nobody tampered with your handshake. Nobody modified your bits in DNet1, or nobody modified your public key or something like that. And that's how applications could do their authentication on top of TCP crypt, by verifying that the session IDs match. And from that session secret, you also derive all your keys for your symmetric ciphers, your MACs, and essentially for your authenticated encryption. So once you have your key material, how do we actually encrypt the data? So we take the user data and we create records out of it. So we have our own framing in the user, in the user data of the TCP portion. And we've got a control byte, a ciphertext length, and a ciphertext. So the control byte currently has only one bit defined, which is the rekey bit. And that's used for, rotating your keys. Question?
Yeah, I have actually a question for the previous slide.
Sure.
One of the things I would say, so you put both the whole ENO transcript into this session secret.
Yep.
Which means that if middle box or anything messes a single bit there, this will generate the different keys, which will then, how do you detect that the keys are wrong? Because that was one of the problems with IKE IETF version 1 was that we used the same thing. We actually put everything, and if there's something wrong, you get an decryption failure. When we didn't notice it anywhere else than have a decryption failure, which was a little bit annoying because you know,
and I think
you would want to like to disable it and fall back to clear text in this case. But I mean, is there some kind of handshake to check out that yes, this is something is wrong or?
Right. So, and I think this was even brought up previously, like, should we normalize the TCP options in a certain way, like if they get reordered or something like that? Yes. David, I don't know if we actually ended up doing that in ENO.
Yeah. So this is David Masias from Stanford. I just wanted to point out that the ENO transcript doesn't mean like the entire like TCP segments, right? The ENO transcript is like a very specific thing that's defined in the ENO document, and it just.
Actually, I was thinking about more or less that because there's no possibility that something goes wrong with this, and it's usually better to get clear feedback that okay, something went wrong, authentication failure, and do something else, than to just get I get random garbage in because my decryption fails for every packet after that point. So yeah, but they will still get an authentication failure in the you don't get feedback that okay, there's something wrong. The session IDs are wrong. Like one way to solve is to send session IDs both ends and notice and oh, they are actually wrong.
Yeah, so we don't have explicit key verification.
Yeah, that's
your question.
So yeah, so you
it's
don't
implicit.
Have,
so the Mac would fail. Yeah.
But it does fail reliably. So if somebody really screws, really bleeps with this in the middle, so that the session keys don't match, you get authenticated encryption failures. You don't get ciphertext going up the stack.
You get a connection hang.
Okay. Yeah. Well.
Okay. Cool. So yeah, so that is a difference with TLS, which has key verification.
Mm-hmm.
Okay, good. So we got our keys and we frame our user data. I was saying there's a control byte. Currently, there's only one bit defined in that control byte, which is a rekey bit used for rotating keys on a long-lived session. There's a length, and then there's a ciphertext. Inside the ciphertext, we replicate some of the TCP flags. So we've got a flag byte. Currently, we replicate the FIN bit and the urgent bit. So we could support, clean connection shutdown and urgent data. If urgent data is present, we include the urgent pointer, and then we just follow it with the actual application data. And all of this is both MAC'd and encrypted. It's authenticated encryption. So I want to talk a little bit about session caching because that was one of the biggest change since Berlin. So if I talked to you in the past and I want to talk to you again, we could optimize things. We don't need to do public key operations anymore, but what we could do is we could take our previous session secret and compute the next session secret for the next communication I have with you. And based on that, I could compute the next session ID and the next encryption keys and so on. And we could keep doing this essentially forever until we just clear our cache. So that's good. It saves us computation power. We don't have to do public key operations anymore. But more importantly, I think it saves us on latency because now we could reestablish a TCP crypt connection in the existing three-way handshake. We no longer have to add that extra fourth leg. So the way it works is it's very similar to the original handshake. We say, hey, I support P521 and P526. But in this case, what we're signaling in the P521 case is I want to resume a session with this session ID. And in this example, it's 392 and so on. So we use ENO's variable length suboptions to signal session resumption. So we're basically saying we want to resume that previous session of P52 with this new session ID. And then in the response, if session resumption was successful, we reply, yeah, sure, let's do that. And we use a variable length suboption with no content. So basically we're saying, yeah, resume 521. It's a variable length suboption and nothing there. So that one bit lets us distinguish whether it's a fresh key negotiation or whether it's a resumption attempt. And then we just send a NAC with the option. And at this point, we could start sending encrypted data right away. So that's how we do session resumption. This is a little bit different from the original TCP crypt spec where, or in fact, from a couple of meetings ago where we would have an explicit TEP for session resumption. So it would be something like TCP crypt dash session resume, and that could have meant any cipher effectively. Here we're being explicit and saying what the cipher is, and that has some nice properties, which I'll talk about later. So really what changed since the last meeting was we cleaned up session resumption. So one of the things we did is that if we're resuming, P521, that also implicitly means that we're willing to start fresh with P521. So we don't have to say, hey, resume P521, and also, by the way, include a couple of extra bytes saying we're also willing to do 521 fresh. So we're kind of saving option space there because it seems like this is a pretty common use pattern. The other thing we've done is we explicitly forbid resuming, two sessions in the same connection. So I can't say resume 521 session ID X and resume 521 session ID Y, because now this creates ambiguity and it also feels like unnatural. There's no real application for this. So we explicitly disallow that. You can only resume one specific session, which intuitively makes sense. And also something that changed that I briefly mentioned from the previous meeting in Berlin, actually this change happened in Berlin, is this notion of being explicit about which cipher you're resuming. So we have an API after you connect with TCP crypt that tells you what cipher was used in your public key negotiation. Previously, we used this generic session resumption TEP in our session ID, in our session resumption, and that would mean that if the app asked what cipher got negotiated, he would get back this answer saying, the session resumption TEP, which is not very informative. It's a little bit weird. Just by changing the protocol, by being explicit, now the API is more kind of homogeneous. It makes more sense. And it also lets us do this implicit notion of, if you want to resume X, you're also willing to start fresh with X. So these are kind of the main changes that happened since the last meeting with regards to session resumption. There were a few other changes in TCP crypt. Some of them were we are explicitly disallowing sending data in the SYN segment. So if you want to do stuff like TFO, it just doesn't work out of the box. You would have to build something on top of TCP crypt and ENO, like David mentioned before. And we also moved the TCP crypt specific APIs to the API document. So now the TCP crypt document just focuses on the crypto aspects. So the document got shorter in that respect too. So that's really it. Not a lot changed. I feel like I've been saying this for the past couple of meetings. In terms of crypt, I think we're getting to the end. It's like really small tweaks and polishings. We haven't gone from packet-based to TLV. The big changes already happened in the last couple of years. Now I think we're really getting to the end. So in terms of the draft, yeah, is it complete? It sounds like we're getting to a last call pretty soon. The implementation, we still need a kernel implementation. We personally haven't made progress on that. And also, which was mentioned by the chairs, we are always seeking for independent implementations. I think this is where we're going to kind of weed out the bugs and possibly even find, ambiguity in the spec. If somebody actually sits down and tries to write code, that's when you spot. We've obviously done that effort, but as authors, sometimes it's kind of harder to see past that.
We'll keep trying looking for people to implement, although I'll comment that there is, in the broader community, significant competition for the attention of likely implementers from both TLS 1.3 and Quick.
I think you should try to, use the Chicago hackathon or something like that, try to get people to come there and, do implementation and testing and so on, because the TLS 1.3 is using hackathons to do all the interrupt testing and writing the code and so on. And I would expect that if you just get, try to get students or something like that to come there and to make implementation of that. It would be
Bring a pile of code to seed the hackathon.
Yeah, I mean, one of the reasons why TLS is successful at the hackathon is that these guys are working on this as their full-time job.
I was thinking about, but there were some student teams this time also for do some other things, and I was thinking about there is some university people here who could actually try to get, and some of the students were actually working from the not traveling, actually they were actually working over the lines and so on. So, but I was just thinking about. I don't have time to do the TCP crypt. Sorry, but I was thinking about that would be something that actually also they take the list of things what people are interested in doing in hackathon. And if you put TCP crypt and you are willing to be there, there might be some other people also being there.
I mean, I think it's a good idea. Yeah,
Great suggestion.
Especially if we start that effort early, maybe we could start identifying some people, and we could write some framework code, to help out.
Write some framework code. Give them the crypto code. Give them the parse code. I mean, basically, give them the functional blocks of code they can reuse, and then you can have people who aren't the experts in the crypto or in option swizzling just go fight the integration into the kernel stack and kernel environment.
Mia Kulevan, there's also a new initiative, I would say, or website, which was called Code Match, and it's now called somehow differently. Forgot the name. It's a website basically where you can say what you need, where you need implementations, and people can look up if they want to do an implementation. I can send the information on the mailing list.
Yeah, please do. Right. Yeah. Okay.
All right. Anything else? All right. I guess we're going to talk about the API.
I'll just point out that David Mazieres from Stanford, if anyone here has deep pockets, of course, I'd be delighted to hire someone at Stanford to do this stuff, but like this thing has gone on for long enough that we kind of ran out of funding. So.
We'll pass the collection plate around.
All right. So you want to talk about the API doc and then bring up the CFRG slides?
Yeah, sounds good. So API doc, who wants to address that? Since we don't have slides for it.
I assume the API doc is functionally complete, and it'll be ready for working group last call along with the other two drafts, right?
Yeah, David Mazieres, that's the idea. Yeah, I think as I was doing the slides, I realized we're missing this mandatory bit, and then maybe there'll be another option to say disable completely versus respond with an empty option. But I think we're a very small patch away from being final, basically.
My inclination is to sequence the last calls, to do a first last call on the protocols, take ENO and TCP crypt as a package in one working group last call, and that one might run a little long because we're going to have to go find outside experts. We know where to find at least one expert on the options. I'm sure we can find one or two other TCP people take a look. Kyle probably has some likely suspects to go triple check the crypto. And then, but not include the API doc in that first working group last call, but send it to working group last call shortly thereafter so that we don't get the docs too disconnected from each other.
Can we, is it possible, this is a kind of a procedural question, but to start TCP crypt and TCP-ENO last calls at the same time, but then...
Oh, I plan to do more than just start at the same time. I plan to send one announcement that says these two drafts are in working group last call, and it's a single working last call on both docs. Yes.
But then could say, I mean, I would imagine it might take more time for crypto review for TCP crypt versus ENO. So do they have to finish at the same time, or could
we get to decide what to do? My preference as working group chair is to chain those two drafts together and just keep them going as a pair, because I think asking someone to review one without the other is a bit much. Whereas I think the API doc is separable. It's got a relationship. I think if the API doc runs a month or 6 weeks behind the main drafts, that's probably okay, because if we find anything, we'll still have time to catch it before the IESG pronounces on any of them. Oh, that was easy.
Yeah.
All right. Okay. Here it is. All right.
All right. So there was some interest among the security area directors and transport and the chairs to get some additional eyeballs looking at the crypto in TCP crypt before and TCP-ENO before we decided to go to working group last call. And there were some. This was the result of some questions that had been sort of bubbling up over the course of the last year and a half or so. And so what I tried to do was compile them into small edible chunks that we could send to the CFRG mailing list and hopefully get some guidance on. And so the first question was around the TCP crypt session ID, and specifically what properties does it need to have, and why does it need to have those properties, or what properties does it have as described by the draft? And so for instance, one of the properties that the system relies on, it feeds into the session ID, feeds the transcript and some other information, the key agreement and whatnot. And so, is it necessary, for instance, for that session ID in order to have the security properties that we want out of this protocol? Is it necessary for that ID to be unpredictable, or does it just need to be unique over all time, so that you can't possibly have two connections with the same ID unless they were engineered by two endpoints colluding, which is kind of dumb. So that was the first question that I had, and there's actually it's probably written better in the email that I sent. So if you want to take a look at that, it's on the CFRG mailing list from October 2nd. And I actually got some really good responses to this. The best response I got was off list, and it was by someone named Nathaniel L. I don't know if any of you guys know who that is. I don't know what L is, but he sent me a fairly long analysis of how he, of how the crypto works and what properties he thinks that it requires. And so I think I sent that to you guys. If anyone else wants to see it, I'm happy to forward it along. I didn't want to put it on the list because he didn't respond to the list. But I'm happy to give it to anyone individually. So just send me or David an email, and I can forward that along. And then there were some other responses as well that were of interest, and those all went to the list. So that was the first question. So the second question that I sent was around the generic. How does the generic nature of ENO as a negotiation protocol for TEPs feed into what the requirements for session IDs are, right? And so the idea here is that that you use an application that makes use of ENO in mandatory application aware mode is assuming, I mean, it's mandating that ENO is available and that there is some TEP that is in common between the two machines, and it produces a session ID that is then used for endpoint authentication. Well, what properties, for instance, does that session ID need to have, and what properties should ENO guarantee to applications that are mandatory application aware? So the situation that I was concerned about, I know I sent an email about this like a year ago, and we stewed around for a while on it, and I didn't really feel satisfied with the answer that came out. The worry that I have is that applications will treat this interface as a black box with the properties of whichever TEP happens to be the default, which in this case would be TCP crypt. But is that it's not without explicitly listing what the properties of the session ID need to be, that assumption may wind up falling over if say the default TEP switches to something completely different that has totally different security properties, right? Like let's say you switch to some TEP that for some reason requires the session ID to remain secret, right? In that case, publishing a signed list of session IDs to a public web server and using that as your out-of-band authentication channel is obviously not something you want to do, because you might be able to derive session keys from that or whatnot. Right, so going back, I made these slides in a rush, so I didn't get them in quite the right speaking order. But so one of the questions I had was, well, does the session ID need to be computationally indistinguishable from random? Well, not really, and in fact, it isn't, because the first byte is always is predictable, or at least it's in a small space. Right, so and even if the session ID, even if every bit of the session ID was slightly biased toward 1, for instance, it would still be secure as long as there was enough entropy in the whole thing to prevent someone from guessing it, and as long as there are mechanisms in place to guarantee that it's unique over all time, right? So what I really would like is some generic crypto guidance on the right way to phrase some of the properties that we want out of this thing. Because I think like right now they're either over-specified or under-specified, and I'm not entirely sure which. I'm also not sure that this is worth all the trouble, because I think this may be one of those situations where people see the spec and they know what it means, but I feel like precision at this time is probably worth pursuing as long as it's not going to consume undue resources.
Yeah, so David Mizera. So I think that in general, the sort of what we've learned in crypto is you want to like over specify these things. Like most people don't actually, most attacks don't actually take the form of like, a chosen ciphertext attack. But the idea is that like if you can survive that game, if your algorithm can survive that game, then it can survive any game. So we've attempted in the ENO draft to be, to err on the side of kind of over specifying, and that's why currently the ENO draft requires all but that first byte to be computationally indistinguishable from random, which that wasn't actually our idea. Someone else suggested it on the mailing list, but that seemed like a nice way of, it seemed to encompass a bunch of things like not enough entropy and things like that you might otherwise worry about. So even though like you probably, you're not going to be seeding your random generator with a session ID, if it is computationally indistinguishable from random, that might like rule out a bunch of other kind of weird things that might be problematic.
Yeah, I mean, I think one of the things that I was sort of hoping for, because there are other protocols that need the specific property that I think you're implying. Like there's an NTP draft going through for NTP security that wants kind of the same thing around session identifiers. The all but the first byte thing just kind of like it hits that button of architectural purity that I have somewhere in my brain. It just sort of bugs me, but again, I'm not sure that it's worth the effort to fix that. It's something that feels kind of like a kludge.
If that, David Black, if specifying it that way, which is that the first byte is on its own and everything else is computationally indistinguishable from random, is sufficient to solve the problem, there may be a tighter necessary condition that we don't have to go looking for. We simply need to be convinced that the problem as we understand it is solved.
I mean, I think that like there's multiple necessary conditions. So one necessary condition is because ENO is so agnostic about the TEP, it's that you cannot ever have two different TEPs producing the same session ID. So I totally agree that first byte is
right. I understand
ugly,
what the first byte is for.
But
yeah.
there's just no other way to do it, right? There is no cryptographers out there, they say you can't find a SHA-512 collision, you can't find a Ketchik collision, but nobody is assuming that you can't, provide one message whose SHA-512 hash is the same as another message is like Ketchik hash, right? Like that's just not a common assumption that people are making, and so we can't make those kinds of assumptions across.
This also,
right. Well, you can. I mean, I actually like a year ago or so, I posted a message to the list describing a naive way of constructing two hashes that are easy. You can find collisions between the two, but not within each one.
and this also helps because it's a variant of what Tara was asking about earlier. If somehow you get confused about which cipher you're using, the session ID immediately deconfuses you. You can take a look at the trace and you can see what went wrong.
Yeah, I think one of the, so just again, I think this is more like food for thought than anything else, and I want to get, what I really want is some input from cryptographers who have worked on stuff like this before, and just sort of understand, maybe get a better understanding of what they think these properties are, should be called. You know, like we talk about like unlinkability, for instance, right? To protect client privacy. What does that really mean? Like, is there a formal definition for that somewhere? And if so, what does that mean for, like, does the session ID as defined in TCP crypt achieve that, and does TCP-ENO properly require that? So I mean, I don't think that this stuff is going to hold up working with class call. Like, that's not my intent. It's more just to get input and see if there are ways to refine the language And if there aren't, then that's fine too.
I mean, David, again, to be clear, unlinkability is not provided by session resumption, right? There's a trade-off, right? So one or the other. But if you're behind a knot, like, and you're resuming TCP crypt, like, even though at the API level they look the same, but like obviously someone could instrument their kernel or their TCP stack and like figure out that they're using session resumption to the same person.
This is DKG. Just wanted to point out that there are two different kinds of unlinkability. One is unlinkability to the peer. The other is unlinkability to the network. And I think session resumption here does provide unlinkability to the network. So just, again, if we're talking about being clear about what we're specifying, don't just say unlinkability. Unlinkability to whom?
And DKG, could you say it at the mic at the moment? Because I got a question for which you might have an insightful answer. The discussion is really interesting. It sounds like we're looking for some precise terms. This working group is not the place to write those definitions. They belong somewhere over in the security area's response to the pervasive monitoring and the like. Where do you have any idea where in the security area that ought to be?
I don't. Sorry, I'm not deep enough in the IETF fine-grained bureaucratic hair splitting to know.
Okay, and in particular, you haven't seen a draft going through over there that does the basic definition of privacy of privacy relevant security terms that Kyle's looking for?
There are several places where that kind of thing has been discussed, but I don't think that they've been directly applied. The folks in the HRPC working group, research group, have actually got a fair number of specific terms trying to map like human rights concepts to technical detail.
Gulp.
I hear you.
Well, but for unlinkability, that's probably useful.
Yeah.
Yeah.
But I don't think that anyone has done a systematized.
All right. At the very least, we could. I'm sorry. At the mic, folks. At the very least, we could record a sense that something more general ought to be done. And we would have found it useful if we could have gotten to these terms, but it's probably a security area activity, not transport.
Let me just say that this is DKG again. I'm not sure that something more general should have been done, right? We have a specific use case here with specific needs, and I think that if we do this specific to TCP crypt, that would be a useful contribution. And if that turns out to be generalizable, that's fine. But I don't want to block this kind of review.
We're all in valid agreement on that.
Okay.
The observation I was trying to make, apparently garbled, is if somebody had written down definitions of the relevant crypto-oriented properties like privacy and version linkability and what that Kyle could have just pointed to, we would have found that useful. But not having that should not block us.
I agree completely. Yeah, I mean, again, I wasn't suggesting holding up the documents on this basis, but it's more like education and dissemination of knowledge about the right ways to phrase these things. It seems like it seems like that stuff doesn't actually exist at the moment, that we need to build up that knowledge and maybe have a set of informational docs that describe these properties more precisely, more formally.
Aaron
Falk. So this conversation makes me think that this is actually a much more general topic than just this working group, right?
Yep.
Yes.
Yes.
DKG's observation that that this is shared in the human rights research group. So I think that maybe this is a reasonable thing to try to bubble up to the IAB, because this is related to the the strategic interest in privacy and pervasive encryption, and it's actually probably one of the more useful dimensions of it from an IETF perspective, which is to try to give some guidance to working groups on linkability and what's the toolkit and what are some candidate requirements that protocol developers might want to include.
Cool. Miria, to put you on the spot, could you get this onto the security area's radar screen in the IESG wrap-up discussions from this week, please? She said yes, which means Miria either do it in the IESG meeting or talk to Kathleen in private.
All right, that's it. Any questions?
Okay, so long discussion, but part probably in good shape. Yeah, I think that's it. Any other comments, questions? Dead cats, rotten tomatoes?
That was a shockingly short session.
Well, that's a really good sign, because thinking about what happened here, more importantly, what didn't happen here, I think I agree with a number of people who said this really does feel like we are at the point where work group last call is the next step and the drafts are ready. So many thanks to all the hard work from the team that's working on the drafts, and I think this is really good.
I think I just did an estimate in my head. I think the flight to session time ratio is about 20 to 1.
Well, now we could all go to TLS where the rest of the working group is.
I think the chair is going to have to do a little bit of before we go to working group last call. We're going to have to round up a few known expert reviewers. I think we're looking for 4. Off the top of my head, 2 for ENO, 2 for TCP Crypt. We know Joe Touch is going to be one of the ENO experts, so I only have to find 1 more. Kyle has to find 2.
Fabulous.
All right. Did anybody not sign the blue sheets? Andrea, did you sign the blue sheets? I think we passed them around while you were talking.
Anyone else? Blue sheets? All right, I guess that's it.
Okay, I think we're done, and I look forward to being in Chicago with Working Group Last Call done, and if nothing major happens during Working Group Last Call, we may not need a meeting in Chicago. That would be a stunningly wonderful outcome. Enjoy the rest of your day in Seoul. Where's the, there it is.
The story of this static stuff on the microphone. Yeah, but people have been getting shocked every time they walk up to the mic. They touch the mic.
Don't worry about me.
A little bit of plan comes together.
Yeah, I think we've basically been at this for about a year, I think, and we've gotten the job done.
Yeah. I'm perfectly happy with how this has gone.
Yeah.
I mean, it certainly could have gone faster, but I think it was fine.
Right, and I think some of what we saw today, which is both of the drafts had visible changes from Berlin to now, indicates that the timing's about right, and we're hitting about where we think we ought to be, and we're hitting the
All right. Well, David, if I don't see you again before